Good evening, pre-algebra. Mr. Lawrence here with your flipped lesson for today. It's going to be a continuation of last night's lesson in the class you saw. I'm going to tend to focus more on the application problems. This time, let's say, well, we'll start with just a warm-up one. We have the problem 12 less than the quotient of a number and 3 is at most 2. Again, we're going to dissect this sentence. We're going to find our variable, which is right there. Okay, let's call it x. What do we need to do about x? Well, we need the quotient, which means divide, of x and 3. The quotient of x and 3. That means x divided by 3. Now we need 12 less than that. How do I take 12 less? Well, I subtract 12. All right, is at most 2. 2 is at most 2. Well, let's see here. There's 2. This side here can be 2. It can be 1. It could be 1.5. It could be 0. Can't be 3 because this is at most 2. So that means that the 2 is going to be larger than the left-hand side. The left-hand side could be 2, so I'll make it equals. Because that's what at most means. It's a less than or equal to. Yes. All right, so let's solve this inequality. Listening to Saddam, I will add 12 to both sides. And those will cancel. I'll get x over 3 less than or equal to 14. Right? X is not alone, therefore I will get x alone by multiplying because it's attached to a 3 by division. The 3's will cancel. X will be less than or equal to 3 times 4 is 2, carry the 1, 42. X is less than or equal to 42. If I graph that on a number line, I'll get something like this. 42, 41, 43 over there. My point will be closed, again because it's equals, right? Sorry, it's supposed to be an arrow. Now I need the numbers that make this true. Blank less than or equal to 42. Which one of those numbers works, 41 or 43? Well, I think 41 works. So I will shade towards the 41, and there we are. Okay, let's say we have a problem like this. The perimeter of a triangle is 15 centimeters. The shortest side of the triangle is 1 centimeter less than the middle side. The longest side of the triangle is 1 centimeter more than the middle side. How long are the sides of the triangle? And in this case, it is implied that we need to find all 3 sides. Why? Because it says how long are the sides. That is a plural term. All right, probably making you dizzy there. Let's first of all draw a triangle, and I must tell you, I've been practicing my triangles. Look at how awesome I am. I've drawn a beautiful triangle. Now, one thing I will notice in this problem, I will notice that the word middle, the middle side, shows up here, and it also shows up there. I'm going to start with the middle side. Why? Because the shortest side is defined by the middle side. Well, in this triangle, I intentionally draw a triangle that has 3 different lengths. I don't know how long the middle side is, so I'll tell you what, I will call it x. You could call it m if you wanted to. Now, I'm not going to run and label the short side and long side like S and L, because if I did that, I would have 3 variables, and I don't know how to solve an equation with 3 different variables. Actually, nobody does. All right. I do know, though, that the shortest side of the triangle is 1 centimeter less than the middle side. Well, if the middle side is x, 1 centimeter less than that must be x minus 1. Think of those problems where we counted up to a number n, and then we considered a number right before n. It would be like n minus 1, right? Well, if I want 1 centimeter less than some unknown number, I just take 1 away. Now, the longest side, which would be this one in this particular triangle, is 1 centimeter more than the middle side. Well, I know that the middle side is x, so therefore that's x plus 1. I also know that the perimeter, which means the distance around the polygon, is 15 centimeters. So I'm going to add up all three sides of the triangle, and when I do that, that has to equal 18. So we'll start with the longest side. That's x plus 1. The shortest side is x minus 1. And then the third side is, the middle side is just plain old x. That has to equal 15. Since those x's and those minus 1's are on the same side of the equal sign, I will combine my like terms. I'm going to circle my x terms in blue. I'm going to make sure to grab the signs that go with them. And I'm going to box my non-x terms with their signs in black. I'll add up my circles, I'll add up my boxes. This is one way to do it. Highlighters work really, really well, by the way. All right, well, I've got 1 plus 1 plus 1, x plus x plus x. Looks like I have 3 x's. Now the plus 1 and a minus 1, they cancel each other out. Equals 15 comes along for the ride. I have a one-step equation. I'll divide each side by 3 to get the x alone, and I will find out that x must equal 5 centimeters. Well, if x equals 5 centimeters, then x plus 1 must be 6 centimeters. And x minus 1 must equal 4 centimeters. Just to check my work, I can add up 6, 4, and 5 and see if it equals 15, because remember, the perimeter of the shape must be 15. And sure enough, 6 plus 4 is 10, plus 5. 15 centimeters is the perimeter. I've done the problem very well. I can pat myself on the back. All right, let's look at one more example here. Hold on, let me get a blank page. The length of a rectangle is 2 less than 3 times the width. If the perimeter of the rectangle is 76 feet, what are the length and width of the rectangle? Well, I need a rectangle. I'm not in draw mode. I need a rectangle. Thank you very much. Okay, now let's see here. 2 less. I know I'm going to have to subtract 2 from something. I need 3 times the width. 3w, right? The length, L, I'm going to call the length L, is 2 less than 3 times the width. Ah. So I know for the lengths, I'll go 3w minus 2. And this length will be the same, 3w minus 2. Why? Because it's a rectangle. Well, how long do you suppose the width is? Or how wide do you suppose the width is? Well, I've got a w sitting here. I don't know, so I'm just going to put a w. There we go. I know that altogether the perimeter makes 76 feet. So I am going to take a walk around this polygon, this rectangle, add up all my w's, add up all my non-w's. Well, let me see, I'll do this the long way again. I'm going to have 3w minus 2 plus a w plus a 3w minus 2 plus a w. That has to equal 76. Again, I'll circle my w terms, grabbing the sign that is in front of them. I'll box my non-w terms, grabbing the sign that's in front of them. Now you got to be careful on this one. Okay, I've got 3 w's here. I've got 4 w's now. 3 more is up to 7 w's. 1 more is 8 w's. Now these boxes, don't you dare try to tell me they cancel out. You know they don't cancel out. They are not positive 2 minus 2. They are not negative 2 plus 2. They're both negative. Look, if you know what 2 plus 2 is, which I'm sure you do, then you must know what negative 2 minus 2. Minus 2. Oops, I'm not in draw mode. Let's see here. There we go. Well, it's the same problem, only I keep the sign. Yeah. 2 plus 2 is 4. Positive 4, right? Positive 2, positive 2, positive 4. A negative 2 gives me a negative 4. So I have minus 4, and that equals 76. Now it's just a two-step equation. I'll listen to Saddam, who tells me to undo the subtraction first. 8w equals 80. And I will divide by 8 and divide by 8. W equals 10. So the width of this rectangle must be 10 feet. How do I figure out the length? Well, I take the 10 and I put it in here. 3 times 10 minus 2. Let me get rid of this other work here so it's not confusing. Okay, so I do 3 times 10 and get 30. 30 minus 2, I get 28. So the length must equal 28 feet. The width must equal 10 feet. And just to check, if I take 28, 28, 28, 10, and 10, what am I doing? I'm adding up all four sides. 8 and 8 is 16. Carry the 1, 2, 4, 5, 6, 7, 76. Look at that. Isn't that the perimeter of the original problem? It sure is. All right, pre-algebra, that's your lesson for today. Now, we will be having a test on Tuesday. I'm not sure if I've mentioned that yet. You will have to solve two-step equations, two-step inequalities, multi-step equations, multi-step inequalities, graph on a number line, and you'll also have to be able to translate and solve. So those of you that have really been caring about your grades, have been working hard. I know Kareem, you want to be an astronomer now. You've been really doing your best. Janie, I've been so proud of you. You've been working hard. Jamie, you're doing a great job. Tony, you're doing an awesome job. Christine's been working hard. I know there's so many of you giving me your best all the time. Alexandra comes to mind. There's lots more. Mr. Hevesy has always been doing his best. You've got to prepare. There will be a review lesson over the weekend, and we'll get a little practice on Monday, but you've got to prepare for this test. Don't blow it off. None of you are stupid. You are all intelligent. You just have to put the effort in. You have to care. I know you can do it. All right, this is Mr. Lawrence signing off. We'll see you tomorrow at school. Good night, everybody.